Okay, in FST and AP Stats, I think even in Advanced Algebra, you look at something called correlation and linear regression. So the idea is that you have two variables. You're comparing two sets of numbers here, and they're paired, which means you can plot a scatter plot of things like this. And so what I'm going to compare here, the example I'm going to do, is that I'm going to do the number of games played by a player, and then their win percentage. Now, my thought was, if I look at the top grandmasters in StarCraft 2, and I look at the number of games they played and compare it to the win percentage, I thought I would see a positive correlation. People who play more in the higher leagues probably have a higher win percentage. And so I just want to talk about two things here that you might know already, but that's okay. There's the R squared, and then there is the regression line. So that regression line is actually this, y equals mx plus b. If you use y equals mx plus b, you should be able to predict things once you get the line. So if there really was a good fit here, I might be able to say, well, if you are this type of player right there, you should expect to get a percentage of that on the ladder if you're a grandmaster. Okay, but what we're really going to focus on here, we're going to focus on the r squared. This is approximately, so I'm going to use approximately the sign here, approximately the percentage that is explained. So I'm kind of glossing over a lot of details here, but if you get an r squared of like 10.10, you know that the win percentage is explained or related to the number of games a person played about 10%. That's not very good. If it's 0.9, you know that 90% of the change in win percentage is explained by games or vice versa. Approximately. So what I did was, I went and I looked at the games played right here, and then the win percentage of these top Grandmaster players. One that you might want to know is that you should probably paste into Excel so that you can select columns at a time. Back here, I try to select a column and I select everything. So I copy and paste the table, and then I just selected the ratio and the losses, and I copied and pasted into GeoGebra. Alright, so here's my information here. The wins and the ratio for each player. If you select all the data, click on the arrow and do two variable regression analysis, it will do the work for you. Alright, there we go. Had trouble getting that up for a second. Alright, so looking at this, kind of looks like we have a positive relationship here. As you go further in games, you have a higher win percentage. So over here, you should press this so you can get the statistics. And then here, you could do linear. Alright, so I drew my line here. And if you go over to the side here, the r squared is calculated for you. That's 0.103. So approximately 10% of the variation is explained in this relationship. That is not a good relationship. That means that actually the number of games probably doesn't affect your overall win percentage at all, which probably makes some sense. It doesn't matter how many games you play, your win percentage is probably fixed. So if you play 100 games or 1,000 games, you're probably going to have the same percentage. But this is a statistical way to show that those variables are not actually that related. And so that is a conclusion. I can say, like, my hypothesis was that those variables were not related, and the alternative was that actually they did explain each other. And we would have to just go with, I think they are not related. And so in your presentation, you could save this picture. You can use that picture with the r squared to explain, hey, these aren't that strong of a relationship. Okay, so you can do that fully in GeoGebra, or you can actually do that in Excel too. I'm not going to explain that part because it's a lot more work, but that is up to you. Again, this is if you want to compare, like if you have players with stats and you want to see if they go together. This is how you would compare two different variables like that.